Hi, I'm Dave Chapman from J&J Automation in the UK. This is part one of a two-part video to demonstrate the installation and function of our plug-and-play battery fail-safe system, which is used to convert an on-off or power-open, power-close electric actuator into a fail-safe electric actuator. First of all, I'll demonstrate the use of the on-off actuator. We remove the DIN plugs, we connect a power supply to it. At the moment the command signal is to open, so the actuator is not moving. The LED status light is on. Please watch the separate video on the LED status light to see the benefit and features of the LED status light. It's a super feature and it's unique to us. So if I now send the actuator a closed signal, the actuator will run into the closed position, but it's being powered externally from its external power source. We're now in the closed position, and if I drive it into the open position but simulate a power out halfway through the stroke, the actuator will stay put because it has no electrical supply to drive it any further. So as we're now closing, if I simulate a power failure, the actuator will stay put. The LED light goes out because there's no power supply to the actuator. We're now going to install the fail-safe system and show you how the unique plug-and-play battery fail-safe system from J&J works. This video will stop at the end of the installation of the product, and then the following video will show the actual movement itself of a fail-safe electric actuator. So, to remove the actuator, we'll just drive it into the open position. Okay. To remove the manual override lever, you simply prise it up. It's held in with a pin through the main drive shaft. Remove the 6 cover cap screws. I've actually removed the other 5 to save time. And remove the cover. Inside the actuator, you'll see on the main circuit board that there are a number of sockets, and we're going to use this particular socket down here to convert the actuator into a fail-safe actuator. Contained within the BSR kit, the battery spring return kit, although there are no mechanical springs, we're just simply providing an alternate power supply to the actuator from the battery, is a printed circuit board which provides the trickle charging system. This plugs in here, and there's actually a locating point here where it can be secured, and there's a screw inside a little plastic bag that comes with the kit. I'm not going to do that just to save time for the purpose of the video. The battery is supplied, and again there is a long screw that is supplied in the kit itself. To save time, I've actually fitted that screw. But there's also a little spigot on the base of the actuator which goes into the base of the battery so that the battery can't twist once it's installed. So we simply push fit the battery onto the spigot. We then secure it with the screw. Don't over tighten this because you're just compressing the battery and it's not necessary. It's purely and simply to stop the battery from moving around within the actuator itself. And then we just connect the battery into the printed circuit board that we've just installed. We've now converted this on-off actuator into a fail-safe actuator. We'll replace the cover. We'll first of all make sure that the seal is still in place. I checked that as it went across, but I thought I'd make the point to show you. If that seal isn't in place, we'd lose our ingress protection of the actuator. And then we simply replace all the cover screws, tighten them down. I'll only do these 2. We replace the pin through the output shaft and replace the handle. So this is now a fail-safe electric actuator. If you go on to the next video, I'll show you the function of the battery within the actuator.